then. Okay, so Matlab Workshop number 3.
Don't worry about it.
Sounds good. Okay. We're gonna go over just some basic functions, and then we'll cover how to write loops, and then we'll go over scripts and the difference between scripts and functions. Okay. So we kind of talked about. Do you remember the first lesson when we talked about naming variables? And I said stuff like you can do stuff like sine equals 5, and that assigns sine to 5. Now you can't do sine of, like, let's say pi. It won't do it. Do you remember this? Okay. So now we're going to talk about trig functions. So pi is one of them. Okay. Pi is one of them. Pi goes out to however many, way more decimal points than you need. So you're good. And it's stored with infinite precision, like I said before. Clear CLC. So all trig functions in MATLAB work in radians. Yeah. So if I do sine of 1, that's not 1 degree, that's 1 radian. And I assume you guys know what radians are and degrees are. Okay, good. Just making sure. And then arc sine also works the same way. Gives it to you in radians, pi over 2. If you want to do it in, also arc sine is a sine. This is arc sine. Right? A sine works weirdly in that a sine does it normally. So a sine does it so that it gives you the arc sine. We have a tan, right? A tan gives you an answer in the second and third quadrant. Or sorry, the first and fourth quadrant. It won't give you an answer in the second and third quadrant. Does that make sense? So if you draw your thing, first, second, third, fourth, it won't give you an answer in these two. It'll only give you answers in these two. So if you plug in a negative, it'll give it to you over here. If you plug in a positive, it'll give it to you over here. But it won't do that thing where it checks the x and the y and tells you whether it's down there. So there's another function called a tan d. A tan 2d. Like this. A tan 2d. Oh, also, should I mention this too? If you put d in front of it, that does it in what's the opposite of radians? Degrees. There you go. Yeah, it's been a long day. So a tan 2d. How this works is you do an x and a y. Do you see that? Or y and an x. So give me 0.5, negative 0.5. And that gives you in degrees where it is. And 135 is over here. Yeah. So that gives it to you in the second quadrant. Okay. All right. So yeah. So that's your basic functions. Is you have sine, cosine, tangent, all those other guys, cosecant, secant.
So do the arc or do the inverse the inverse trig functions just return whatever value is in the positive quadrants?
Quadrants. Yeah. Except if you do 2D or you do the a tan 2.
Okay.
Does that make sense?
So and you do a tan 2 and give it to you in radians.
Right, in radians.
Whichever the actual
quadrant is. Right. And so, because the reason is when you do a tan d, let's say just instead of a tan, let's just do a tan, right? If you do just a tan, it asks for one argument. So you put in a number and you put in like negative 0.5. And it gives you in a value. And that value is a negative radians. Because it doesn't know the x and the y value, right? So it can't actually figure out what quadrant it is because tangent's dividing, right? Sine and cosine don't do this because sine and cosine have one value all the way throughout. Yeah. Okay. Or also sine and cosine won't return you negative; it'll only go in the positive direction. If it returns you in the negative direction, there's a MATLAB 2014 will do that. If you're in 2014, it'll go negative. 2015 will do this. Okay. Perfect. Some other basic functions. This out. exp, that's e raised to the whatever. Good. We have natural log. Come on. Sorry. Did convert it to Wolfram. You have to do log. Not working. There you go. Yeah. And then if you want to do log base 10, it's log 10. Got it. Maybe we should do a different number. There you go. One thing that you can do is if you don't know what a function does, I don't know if you covered this with the help function. Did we go over this? Okay, yeah, but you can just do like, and it pops up the script. Do you remember this? Okay, yeah, just make sure. MATLAB follows order of operations, like I said before. You can do, I don't know if I've ever shown you this before. So if I do this, it assigns a equals 5, right? If I do b equals 10, that suppresses it. If I do, I can keep typing after the semicolon. It's like in other languages where you can put it all in one. Semicolons also ends the statement for you. Yeah. So that's just helpful if you want to condense stuff. Square root. Good. Absolute value. I know these are all super basic, but just, you just need to use them. And then nth root. It's like that. And so nth root is, we'll return x raised to the 1 over n, right? So x is going to be like, let's say 10. We take, or let's do 125. We do the third root. Maybe 5. Yeah, pretty self-explanatory. You can also do non-whole number roots. That, I don't know when you'd ever use that, but that's a thing. Okay, so now I'm going to go over a quick homework problem that I had in class, and I'm going to walk you guys through it, and we're just going to, learn how to do it. So, what majors are you guys? Majors? Mechanical? Okay. So you guys, I don't know if you remember Gen Chem or if you took Gen Chem or anything, but there's equations of states, like the Van der Waals equation of state, ideal gas law. You remember all this? Okay. So we're going to do one called d to Ricci. Let me pull it up for you guys. It's that guy. All right, so we're gonna create a calculator on Matlab that lets you plug in some values and it returns the value for just calculate a pressure. So we'll plug in the other equations or plug in the other variables and it'll pop out a pressure. It's pretty simple, but it's just gonna go over how to use functions, how to use scripts, that kind of stuff. And we're gonna write it in 2 ways. We're gonna write it using a script and we're gonna use it writing a function. Okay. So first thing we'll do, open up a new script. Yeah. You know what I can do? Let me see if I have this actually. All right, take it back. Let's do Rayleigh Kwong because I already have it written. Okay. Do you know how to spell Rayleigh Kwong?
R-E-D-L-I-C-H.
There it is. It's that guy. Kind of complex, kind of out of the way. And I don't know if you guys remember or if you ever learned what reduced pressures were, critical temperatures, and all that kind of stuff. But this just gives you a pressure from a bunch of values. Okay. So we're going to go ahead and code this in 2 different ways. First time we're going to code it with a script. Second, we're going to code it with a function. And you get to see the differences between both. All right. So pull this up. So can I zoom out on this? Is this okay for you guys? Okay. So how I wrote this was, this is the script. That's the function file. So this is just the input where I go through. And so you can call the script like how you normally call scripts. Where, did you go around and call scripts? Did you cover any of this?
We covered them, but not in too much detail.
Okay, well, a script is basically something that you run and it's executable. A function is something where you have to put in arguments into parameters and it returns an answer for you. You don't really have any kind of control over it besides what you put in the parameters. Scripts you have a little more control over. Okay, so to call a script, you just type it in. Make sure your directory is the same. So just go over to whichever folder you write these in. Make sure that's the same. And you haven't written this yet, but basically do it. And it gives you to like this, where you can, since I put in input statements, you can go ahead and just input stuff as you go. So I can put in like 300, 500, 1 to 10, and it pops out a pressure. It's not a valid pressure. It's negative. You can't have negative pressure, but because your temperature flows above critical. But what I'm saying is, this is how scripts work, where you call the script, and whatever it does, since I put in inputs, it asks for inputs. If I did the exact same thing with the function, which I'll go over in a second, you see how it has these parameters here? T, V, T, C, P, C. You have to enter them in the order that they, ask for, and you have to enter it like this. And it should pop out. There you go. You see that? So it looks like sine and cosine. You remember how it gave you the little parameters? It basically asks you for the parameters. So I'm gonna go ahead and put in the same ones. And it's the same answer. It's just being dumb. So. We're gonna go over scripts really quick. Let's start with scripts. So, did you see when I clicked new script, it was up in this corner? So I can't pop it up again. And I think you can go Command N, Control N. I think that creates a new script too. Try that out. Okay. Anyways, you can create a new script, and a new script file is basically where you can, create a file. These are comments. We went over those. This is how you go over inputs. I believe we went over this too. Go over inputs. Yeah. So what I did here was I basically went, give me an input for a T, input for a critical temperature, input for a critical pressure, and a volume input. Okay. So that's the thing about scripts is these are stored inside of this script workspace, and you can't access that from here. So after you run a script, you can't really call temperature. That's stored inside of this. So unless you store temperature in this workspace, it won't be stored here. Does that make sense? So I put 300 for temperature, right? That's not going to be stored here anymore. That's going to be in here, but it's not accessible from here. That kind of makes sense? Okay. So, and then here, I'm just going over, this is just a calculation. You don't really have to worry about it. Ideal gas law, A and B, and you just go through and calculate it. Pretty simple, right? So this is how, that's the thing about scripts is you have to ask for user inputs. When you go to a function, the first thing you do is you write function. This is what's being returned. This is the name of the function, and these are the parameters. Are we good? And then here's what the inputs we had last time. So what I'm doing here is since the inputs are already given to you, you don't actually have to ask for inputs from the user. So then you can just go ahead and skip the calculations. Does that make sense? Okay. Also your output, you say I put P here, and P is a vector, or it's an array. Have we gone over that? Gone over arrays? Yeah. Sorry, I teach the Java class too, so we're on different spots. This is an array, right? What you could also do is you could actually go like that. And that means that when I call it, it'll return an array of P, A, and B. Does that make sense? Are you guys getting that? It's easier to just do it like that, because then when let's say you call this function, don't remember any of this. Okay, so it says column 1, column 2, column 3. Those are the three, the PA, the A, and the B value calculated, right? So from here, you can then go ahead and extract whatever value you want, right? But if you enter it as a vector, if you make the output as a vector, then it'll only show up as vectors. You can't really extract it like that. You have to assign those to variables. It gets a little more complex. So I recommend doing it this way. Are we good with that? Okay. Any questions? No? We're all good? So do you guys think you can write a function yourself or a script yourself? Okay. So let's go over just a simple example. Write this in script form and a function form. This guys, it's your little homework right now. You need to write a script or a function. You need to write both, where you ask the user for an input. Ask the user for like some number n, and you're just going to return the factorial of that. Okay? Have you gone over loops? Okay, wait, let's go over loops really quick. I take that back. You can't do this yet. All right. So, who knows other languages? Everybody here? Except you. Okay, that's okay. So loops are the same in most languages. Let me pull up the notes really quick. What day was it? All right, so, and this is the new script button. Remember I showed you that? Okay. So let's do a script where let's create a function where you're going to do the inverse square, which is going to be, you're going to create a series from the sum of 1 to n of 1 over I squared. I'll show it to you. Like, it'll make more sense when I type it out. So what we're going to do is you're going to write function, that's how you always start it, y equals like that. Okay? So y equals 0. Okay. So we're going to say while I is less than or equal to n. And this is kind of what I wanted you guys to do with the factorial, but I'm going to do it in a different way. A while loop is the same as in most languages. Since you don't know what a while loop is, I'll cover that really quick. A while loop has a condition and a terminating condition. Okay? And what you're saying here is, while this thing is less than this thing, do whatever's inside of this. Okay? So while I, which is equal to 1, is less than or equal to n, which is the number that you input, keep executing whatever's inside of here. The moment you get I greater than n, stop the loop and just hop out of that loop. Okay? So here, let's say we put n equal to 1, it'll run once. Put n equal to 5, it'll run 5 times. That kind of makes sense. If we iterate I by 1, that makes sense. So if we go by 1 each time, it'll run 1 time if you put 1, 5 times if you put 5, and so on and so forth. One thing to be careful about while loops is make sure you increment this. Make sure you increment this. Don't just leave this as, because if you don't increment this loop will run forever.
What? You're initializing y to 0, is that because the function, or the...
Yeah, you actually don't need to initialize it. You can go and initialize it inside, but I'm going to use y as like a sum kind of thing. So I just wanted to have start at 0. So this is your while loop right here. This is your function. Inside this while loop, how it's going to start is you're going to put in some number, and it's going to go and go, okay, y equals 0, I equals 1. It's going to go while I is less than this number. So let's say we'll put in 10. So then I'll go through and say y equals y plus 1 over I squared. Well, I is equal to 1 initially, so 1 over 1 squared is just 1 over 1. So then y plus 1 is just, so y equals 1. Does that make sense? Then you plug in 2, and you get 2 squared is 4, so it's 1 plus 1 fourth. Actually 1 and 4. 3 you get 1 and 4th plus 1 ninth. We're kind of getting that. And then this, every time it after it goes to here, it comes down here, and it says, okay, I equals I plus 1. So it increments it up by 1. If you wanted to do every other one, you just do I equals I plus 2. There you go. Yeah. Make sense? Loops are pretty simple. It's really self-explanatory. Like, it's exactly like what you think it is. Let me see if I have this saved already. No, we're good. Okay. There you go. So actually, let's do of 1. You get 1, right? If you do of 2, you get 1 and a fourth. 3, you get 1 and a fourth plus that 1 ninth. Does that make sense? Do you guys see how that works? Okay. Now let's do plus 3. If I call the same thing, it's going to go every third one. You see how 1 still doesn't change? Because the first time it still only goes up by 1, and then it hops out of that loop. So we go 3, it jumps up by 3. So even when it gets to, do you get what I'm saying? So it starts at 1, then it adds 3 to it, so you get 4. So until I call 4 here, it won't increment. Yeah? Is everyone getting this so far? Raise your hand if you're confused. Okay, perfect. Just making sure. But that's how you increment stuff. And so the benefit of a while loop is that you can change the increment. You can make the increment any size that you want. So here I can make it I plus 3. You have control over the initial condition. You have control over this guy, which is the parameter. You have control over how much you increment it by. And that gives you a lot of control. While loops they help you, They're really useful if you want to just control all of it, but for loops are usually faster. So let me do this.
Show them what happens when you don't increment it.
Oh yeah, that's a good idea. Get rid of this guy. I'm gonna call the same thing again, and it's gonna keep running. You see how it says busy? Just Command C to quit. Control C. Control C. That what happened there is it's an infinite loop, and so it goes through and goes while I is less than this, add this. So it comes down here and goes, okay, well I is equal to 1, add whatever 1 squared, which is 1. So it goes y equals 1. So now y is equal to 1. Doesn't see anything, so it comes back. I is still equal to 1. So it does it again, and does it again, and does it again, does it again. Right. I wonder if I can actually. Does Matlab let you like, if you write a script, would it let you pull out that number after?
Just display it.
I'll do that. And so you're kind of seeing what's happening here. And it's going up by 1 every time. So it just looped through that 354,448 times. You don't want to let it do that. That takes up a lot of memory, a lot of space. Not good for you. You leave that for too long, it'll crash your computer. So that's the danger of while loops is you need to make sure that you increment. And sometimes like you'll do homework or you'll do something in work or whatever it is, and it'll take like 5 seconds to do. Be careful, because anything over 5, 10, 15 seconds, you're venturing into the territory of like it might be a while loop somewhere that's gone crazy. Right? Does that make sense? All right. Just draw that really quick. So now we're going to go back to vectors really quick. And we're going to say we're going to sum up all the elements of a vector. So let's say we have a vector v, which goes 1 through 50. Also press it. Right. So if you print out v, it's 1 through 50. Right. Make sure it's still there. Yep. And remember, CLC clears the window, clears the variables. Right. So let's say you wanted to sum up all the elements through 1 through 50. Yeah. How would you do that? Right side.
Sum B.
You can do some B. That's true. Nice. All right. But we're going to go over loops. So how would you do it with loops? All right. So let's say we have 4 things. Forget about everything else. How you sum this is you go to the first element, add this to the sum, then go to the next element, add this to the sum, next element, add this to the sum, next element, add this to the sum. Pretty self-explanatory, right? So now the question is, how do you write a loop that does this? Well, and also you need to call all the elements of the vector. So what we'll do is we'll say function y equals v sum. Okay. A is the vector that you want to input. Y equals 0, and equals length of A. Yeah, and we covered the length function. Length just gives you the number of the elements. Yeah, okay. So we'll go while I is less than or equal to, anyone want to guess what the terminating condition is? N. There you go. So 50 would work if the only thing you were summing up is 50 long. But let's say you want to put in 100 or 200, 300. So usually you want this to be some kind of, like, you want both those to be variables. In some cases you don't. In some cases you want to let it do whatever. But just make sure that you usually want to have it as variables so you can change it as you go. Right. So now we'll go. Y is the sum. You want to add to the sum the element of that vector at that point. So how you'll call it, you'll say A and I. Yeah? So what that goes is when it's I equals 1, and also remember MATLAB starts at 1, so it'll go, starts vectors at 1. So it'll go here and go, okay, at 1, it's going to go y equals 0, and it's going to go 0 plus the element here, which is 1. So now sum equals 1. Now it's going to go over 1. I'm going to increment it up by 1. Yeah? Now it goes up 1, and it goes, okay, well, the sum now equals the sum plus the value here. then it's the sum plus value here, then the sum plus value here. And it keeps going until it hits the length. So here it goes 1, 2, 3, 4, length equals 4. The length is 4. So it's going to loop through 4 times. Are we good?
Can you not increment by just doing like y plus equals or like
Does
like
is it?
other
I don't think there is a
languages?
plus equals in
You can't
Matlab.
do it.
No,
Wish there were.
you gotta do I plus equals 1. So we can do. There you go. Good. Okay. Do you guys want to go through and I want you to make a function where it's very like this. So first, I want you to in your workspace. I want you to go through and create a vector of all the numbers from 1 through 100. Okay. Then I want you to write a script where it takes each element of the vector, every third element of the vector, and multiplies it to the sum and gives you the answer. Does everyone get that? Do you get what I'm saying? Okay. Try that.
What does it do again? Sorry.
Alright, so you want to go through every third element, and you want to take that element, multiply to what's that called? Cube it and add it to the sum. I'm gonna write it down. Okay.
Find the sum of the
Cubes of every
element
third.
in the vector.
Every third element.
Oh, every.
I just wanted to screw with them, give it something. So, vector from 1 to 100. Take every third. Take every third element. Find some cubes.
Probably didn't say.
Does that kind of make sense? So for this guy, it would go 1 cubed is 1, and then go up 3, and then go 4 cubed. Add those two up. Sorry, that wasn't really clear, but does that make sense now? And there's multiple ways to do this. So I want to see if someone can come up with more than one way to do it.
Just the name of the entire thing.
Function. Now save this as VSUM.
Raise your hand if you need help. Give you guys a few minutes to go through it.
You can call VSUM in any script you want. You can call it here or you can call it.
Just do something. Alright, thank you.
Has anyone got it yet? Anyone need help? The reason I gave this instead of just like adding up the numbers is because you need to learn how to increment and you need to learn how to use cubes and sum and how to write a function. It's just a lot of things. I know it's a little confusing, but it works. Let me know if you get it.
If you do a for loop, is it the same as
You can do for loop.
C, where it does initial increment?
I'll go over for loops next. Write it with the while loop. I'll go over for loops next. The next activity is going to do the exact same thing with the for loop. So jump on the gun a little bit. Got it? I'm also gonna start trying to give you guys more of these assignments in class where I can like just see if you guys get what's going on. I feel like that's better than you just listening to me the entire time. Yeah. Anyone get it? And I can think of 2 ways to do it off the top of my head, but anyone get it? Got it? Okay. You want to walk me through it?
Yeah. What's the syntax look like with the function again? This function and then name.
A sum, let's say, equals name. What did you name it?
I didn't give it a name.
Cube sum. Good.
Yeah.
Okay.
So
And the syntax is it goes function, return, name, and then parameters.
okay. I just did y equals parentheses a, so
Okay.
a little bit.
Yeah.
Error. So let's see. So sum equals 0 first, right?
Okay.
I equals 1 for our counter,
Got it.
and then n equals the length of a.
Perfect.
And then while I is less than or equal to n.
Do you need those parentheses or no? I don't think so.
Wait, no.
I don't remember. But yeah. Well, I is less than or equal to n. Got it.
Y equals y plus
Or sum equals.
a parentheses I cubed. Oh, sorry, yeah.
You're good. Like that.
Yeah.
Okay. And then
I equals I plus 3.
perfect.
So you need semicolons.
You don't need semicolons, but it'll suppress the output. Otherwise, you're gonna get every. It's gonna here. I'll show you actually.
Oh, it'll print every single iteration.
So if I do cube sum of 1, like that, or if I get rid of this, just gonna.
Shows you it sums it for every single.
Yeah, so it shows you every iteration. So this is the first one, second one, third one, fourth one, fifth one, sixth one, all the way down. Which I guess is helpful, but if you're summing big stuff, there's no point. So
The reason for I plus 3, if it's every third,
Yeah.
plus 2. If it's starting at 1, then you add 2 to that.
then we'd be on the third one, and then you'd go fifth one, seventh one, ninth one. Isn't that every second?
Oh, because I is you count, right?
If you start at 0, then it's every third, because then it goes 0, 3, 6, 9.
Okay.
That's every third, right?
I still have to add 3.
Yeah. What I'm saying is, if you start at 0, then you add 3, it'd go to 6, or 3, then go to 6, then go to 9. That's every third. But you'd go 1, 4, 7. Does that make sense? Yeah. So, does everyone get that? Raise your hand if that code does not make sense. Okay. I'm gonna teach you for loops, and then I'm gonna let you work on this exact assignment with the for loop, and that's gonna be the end of this. And the goal of this is so that whoever do you guys get the while loop to work? Did anyone besides him get it to work? Okay. So then, yeah. But then the next goal is I want you to try. The next goal is I want you to write it with a for loop, just to show you the differences. So we're gonna go over for loops really quick. The syntax for loop is it goes for start. Do you remember? This is the vector notation. Does that make sense? Do you remember how you can make a vector by saying if I said 1 through 100, maybe do that. So the 1 through 10, give me every 10th one. Does it look familiar? Yeah. So what a for loop does is it actually doesn't. You know how in most languages it creates like a number and iterates through that. So you have a number like I equals 1 and it go 1, 2, 3, 4, 5. What for loops do here is it creates a vector and it loops through the vector. Don't ask me why. So let's scroll up a bit actually. This is the general what do you call it? Syntax for it. So let me show you a quick for loop. If I wanted to just write a for loop that goes from for I equals 1 through 10, give me some, just say, I should have done some. Yeah. Also, you can write loops in this. It's kind of weird, but you can write loops here. Do you kind of see what happened there? Where I here, yeah. So I is just equal to 10 right now, right? But that's because I is the 10th element of this vector. So it goes through the vector of 1 through 10, and it says I equals 1. All right, we'll go through the loop, sum equals sum plus 1. Then it goes to I equals 2, does it, I equals 3 does it, I equals 4 does it. If you wanted to do this exact same thing, but you want to do every third one, you just do that, right? Yeah, and sum was already equal to 10. That's why it says 14. I didn't clear sum. So in reality, the sum was 4, which makes sense if you go to every third one. Good? Okay, so, like I said before, can you write cube sum again? Here's the code for it, and there we go. Here's the code for it. Can you write this as a for loop? So I can walk you through this really quick. I won't tell you how to do it, but I'll just say, you have a condition like this, right? What are you going to do with this condition? You got to think about that. Because you can't say while I is less than this. You can't do that with for loop. But you can iterate a set amount of times. So how many times are you going to iterate? You also don't need an increment like this because it increments inside of the for loop, inside of Q. So those are the two things you need to think about: is what conditions you use, like how many times you loop, and then what's the increment? How do you write the increment? This should be the same. This line should be the same. Try it, and I'll give you guys about 5 minutes. Let's see if you guys can figure it out. Raise your hand if you need help. Both of us are up here. And I know I'm also throwing you out here like fish out of water, just like letting you do it, but I kind of want you guys to just practice writing stuff yourself. You good? Yeah, I know. You're good.
You have trouble, you can just put help.
Yeah.
Or
Help for. Thanks for coming. Oh, do you want to sign in real quick? All right.
I don't have a sign.
Do you want to just publish this?
How do you publish that?
That's a,
I think it's like in my Google Drive. I don't know how to access it.
you don't need. There you go. Oh, wait.
That's fucked up.
I'll let that go through.
Oh, okay.
And then we can just collect names.
In the link.
Yeah. Anyone making progress? Anyone just stuck? Anyone don't know how to start? Anyone just too scared to speak up?
Not function thing.
Uh-huh.
When you define your output, so in the last one we did y, or in this
Mhm,
one we did
sum.
in your for loop, when
Mhm.
you define your variable,
Mhm.
can it be that same thing, or does that have to be something different?
Yeah, so you see how I did some here and some here?
Okay. Gotcha.
Yeah.
You want email?
Hmm?
You want email?
No, I don't think we need to. Okay. Also, when you guys are done, can you guys just combine and sign in? That'd be good. Everyone good? Anyone got it? Raise your hand if you got it. Or if you think you got it. I believe in you. Ask for help if you need it. Start writing it up here. Okay, well. Okay. Anyone get it? Or should I go ahead and reveal the answer? Okay. So, you got to be a little bit clever with this, right? So we'll start at 1. We know the increment's 3. But where do you end? Well, you can just end at n. Right?
Nope.
No.
I don't know why, but
Hmm?
minus 3.
Say that again?
Oh, you already in good. No.
So right. See what happens. Curious to see what it'll say. Probably save it. What did I say was 1 through 100? What's up? Why is he yelling at me?
You have to
Yeah.
do
Why?
pi equals.
Oh, yeah, yeah.
You don't even need
Got it. Got it. I see it. Thank you. There you go. Thank you for catching that. Okay. Do you guys see the difference? This is the difference between for and while loops. While loops can be a little trickier sometimes. Or, well, for loops can be tricky too, actually. But for loops are really defined. They're very structured. You have a start, an increment, and a stop. And your goal is to figure out where's that stop. Yeah? While loops, for loops run for a set amount of time. I mean, yeah, the end isn't set, n changes, but n is a set amount of time. While loops you can use for stuff like where you don't know when it'll end, where you don't know how many iterations you need. Okay? I'll show you an example of that right after this. We'll cover this example in the next class. But I'm just going to show you guys something and then we'll end with that. But do you guys get this? Raise your hand if you have any questions about this. Okay, perfect. And then this one also makes sense, right? So you guys get, and also you can probably figure out how to write this as a script, right? If you want to write this as a script, you would just say input A. A equals input A. Just do that. One more thing that I forgot to mention about this is this sum variable on a function, you do not need to put something here like, you don't need to put sum here just to print it out, or you don't need to say disp sum because that's automatically assumed with the function. In a script, it won't print it out. So you can run scripts and nothing will happen. Like you won't get a variable out of it. You just need to then go and ask it to print out the variable, or ask it to return the variable. Does it make sense? Okay, perfect.
Can you go back to the float really quick?
Yeah.
So if you defined something else other than I after 4, is that possible, or does it have to be I?
Re-
Because you're kind of,
Right,
say you do 4 y equals something.
right here? Sure, why not?
Oh, okay, it just needs to match a variable.
Yeah, because if you have I here, then it's going to yell at you and it's going to say there's no I anywhere. And that's the weird thing is this is the notation you use for a vector, right? And so it actually creates a vector, and then at every iteration of the loop, it gives you the value of the vector. So what this is actually saying is like, you see this call right here? This call is actually what it's doing right here. It's really weird, but it gives you that number there. That's why when you iterate, it goes from 1 through n, so it creates that vector, and then it just takes every third one, right? And another way to do it is to actually go from 1 through n. Remember I said there's multiple ways to do this? So here we added 3, right? What you could do is you could actually say like, oh, well, I could chop this array up into every third one. So you can create a new array, you can create a loop again, where you go through this old array, you just take every third element and add it to this new array, and then do the sum of that. Does that make sense? So instead of skipping every third here, you iterate by 1 here. But before this, you create some kind of new vector, and you take all the elements of that old array, and you just take every third one of those, add it to this new array. And this is slower, but you can go through and create that. So now you have an array of every third one, and then you just go ahead and run this loop. Does that make sense? Can you conceptually get that? And that is slower. It is slower, but I mean, it's another way to do it. What you can do here for this for loop is here you can go 1 through n, and you can create some variable here where you basically say while do we want to if statements, right? Yeah. If I mod 3. No, it's integer division.
It's mod function.
It's not the mod function because this. Yeah. That doesn't look right. Is it that? Someone look up how to do integer division.
It's highlighted.
No. Can you look up how to do the remainder? Someone just Google that. Rem? Okay. Perfect. Let's see if that works. Oh, you know what? I think it's like this, right? There you go. Good? Do I? Sorry. There you go. Now, there's a difference here, though. This number is not the same as this number. I can't show both. But this one's 84,000 something. This one's 88,000. Why do you think that is? It's something really simple. What it does is the first one it starts the first value, then it goes to the fourth value, then it goes to the seventh value. That's the increment, right? Here it goes 1, 2, 3. Oh, 3 works. 4, 5, 6 works. 7, 8, 9 works. So you remember how you said you want to do 3, 6, 9? This is how you do 3, 6, 9. That way it does 1, 4, 7. Does that make sense? Here I'm actually checking to see if the remainder is actually equal to 0. But when you start at 1, the remainder is not equal to 0, so it doesn't work. That's a small little thing. Your homework is to figure out how to do an if statement like this and still have it give the same answer. Okay? I think we can end class here. We covered for loops, while loops, we covered how to write scripts, how to write functions, differences between those two, and just some basic functions like sine, cosine, that kind of stuff. Good? All right. Thank you all so